Welcome to today's numeracy tutorial. Our learning objective today is to divide a 2-digit number by a 1-digit number. As always, we'll get ready for our lesson with a 5-question brain gym. Get ready to warm up. Here are the 5 questions for you to have a go. Okay, question 1 to question 3 were multiplication focused. You may have used short multiplication written method to have calculated the product of 26 and 5. The total is equal to 130. Question 2 and question 3 checks that you can multiply by 10. 12 multiplied by 10 is equal to 120 and 13 times 10 is equal to 130. Number 4 is a place value addition question. 8,120 gives the total 8,120. Question 5 is our time question. The clock's minute hand is pointing to 5, showing that 25 minutes have passed since the start of the hour. This means it is 25 minutes past. We can see that the hour hand has passed the number 10. It is 25 minutes past 10. We write this in digital time like 10:25. Remember, digital time is always the hour, minutes past the hour. Greg is back with a question. He wants us to answer these 2 questions. 56 beanbags have been used in this race. There is an equal number of beanbags in each lane. You can see from the picture there are 4 lanes. How many beanbags are in each lane? He also wants us to find out how far the furthest beanbag is away from the start line. He tells us that there is a beanbag every 10 metres in each lane. You can pause the video and have a go at solving Greg's puzzle. Once you've had a go, put your answers aside and we'll revisit at the end of the tutorial. Now we are ready to focus on our learning today. Today's learning objective is to divide 2-digit numbers by 1-digit number using formal method. There are 85 crayons. They come in packs of 4. How many packs are there? We could try drawing out crayons, but this would take such a long time. We could use counters. 1 counter for every crayon. But this would take an extremely long time as well. And we would very likely make mistakes. It's not easy to put out that many counters into groups of 4 and not lose count. Well, here's the same problem. We're going to use place value grid and formal written method to divide the 2-digit number 84 by a 1-digit number 4. I call this the bus stop method because it reminds me of people waiting at a bus stop. They will be divided up equally into separate buses. Here, 84 will be divided up into groups of 4. Let's show the number 84 with place value counters. Unlike when we multiply, when we divide we start with the greatest place value column. Here it's the tens. We need to ask ourselves, because we're dividing by 4, how many groups of 4 can I make? I can make 2 groups. Therefore, on the written method, I just write 2 above the 8 tens. I now do the same with the ones. I ask myself, how many groups of 4 can I make? Well, that's easy. 1 group. Therefore, on the written method, I write 1 above the 4 ones. The number of packs of crayons would be 21. Using that method, a place value grid and the formal method alongside, have a go at dividing 96 by 3. Pause the video now and try it out. Written with the formal method, 96 is placed under the bus shelter and 3, the number we are dividing by, that's called the divisor, is placed alongside it. Let's look and see what 96 looks like on a place value grid. There are 9 tens and 6 ones. Because we're dividing, we'll start with the greatest place value column. In this case, it's the tens. How many groups of 3 tens can be made from 9 tens? 1, 2, 3. We write the 3 above the 9 tens in the written method. Next we move to the ones place value column. We do exactly the same. How many groups of 3 ones can be made from 6 ones? 1, 2. We write the 2 above the 6 in the formal written method. 96 divided by 3 is equal to 32 equal groups of 3. Let's do the same to answer this question. 34 divided by 2. We write the formal method and place our counters onto the place value grid. Again, we are dividing, so let's begin with the greatest place value column. The tens. How many groups of 2 tens can be made from 3 tens? 1. This calculation is different than the earlier ones we looked at because look, we've a remaining 10. In this case, we write 1 above the 3 in the written method. This shows that we can make 1 group of 2 tens. We need to exchange the remaining 10 into the ones value column. Let's see what this looks like on the place value table. We also need to record this exchange in the formal written method, and we do this by writing a little 1 in the ones column alongside the digit that is already there, which is 4. Notice that I write the exchange to the left-hand side of the digit. So now you can see that we have 14 ones. We continue as before, dividing the ones by asking ourselves how many groups of 2 can be made from 14 ones. Well, let's see. 1, 2, 3, 4, 5, 6, 7. We record this in the formal method above the ones digit, 7. Our answer to 34 divided by 2 is 17. The fancy mathematical name for the answer to a dividing calculation is quotient. The quotient of 34 and 2 is 17. Here's a question involving exchange for you to attempt. Pause the video and have a go. As before, I write the formal written method and place the counters onto the place value grid just to help us see what's going on. We begin by asking how many groups of 4 tens can be made from 7 tens. Well, that's easy, we can see just 1. We record this in the formal written method above the 7. In the tens place, we can see that there are 3 tens remaining. These must be exchanged. We record this exchange in the formal written method by placing a small 3 beside the ones digit, which is 6. Now we have 36 ones to be divided into groups of 4. Using our times table facts, we know that there are 9 groups of 4 in 36. Let's see. We record this above the ones digit in the formal method. What is the quotient of 76 and 4? 19. The answer to our division calculation, which is the quotient, is 19. Let's have a look at this question. Ella has 13 straws. She wants to make them into triangles. How many triangles can she make? We know that all triangles have 3 sides. Therefore, the straws must be grouped into groups of 3. 13 divided by 3. Let's see what this looks like using the straws. Ella can make 4 triangles, and she has 1 straw not in a triangle. It's not in a group of 3. We have 4 groups of 3 and a remainder of 1. We show the remainder of 1 in our answer by writing a small or a capital R with the 1 beside it. Here's your next challenge. Jay has 16 straws. He wants to make them into triangles. How many triangles can he make? Well, the calculation is 16 divided by 3, and we can see clearly that there are 5 triangles, but there's 1 remaining. How would he write that answer? 5 remainder 1. Greg wants to remind us, remainder means that a number does not divide equally and there is some left over. We're going to think a little bit more about our understanding of remainders and how we show this using the formal method of division. 91 divided by 4. As before, we write the formal method and show our counters on the place value grid, which we are using to help us better understand division. Beginning with the greatest place value, we investigate how many groups of 4 we can make from 9 tens. 1, 2. We write the 2 above the 9 tens in the formal method. We have a remaining 1 10, which we must exchange. Let's do that. Don't forget to record that exchange by writing a little 1 in the ones place value in our formal method. Now, how many groups of 4 are there in 11? We can see that there are 2. We record that in the formal method, and then look, we notice there are 3 remaining ones. We record that in our formal method by writing or 3, remainder 3. 91 divided by 4 has a quotient of 22, remainder 3. Now it's your turn to try having a go at dividing a 2-digit number by a 1-digit number, where you will have a remainder. Pause the video now and work through your challenge. You would have recorded the formal written method like that, and then perhaps illustrated counters on the place value grid. Starting with the tens, how many groups of 3 can be made from 5 tens? Well, you can see there's only 1. Record the 1 in the written method, and, like before, we notice that there are 2 remaining 10s that need to be exchanged. We need to show that exchange in the written method, and we do this by writing a little 2 in the ones place. As before, we divide the ones now into groups of 3. We can see that there are 9 groups of 3 within 28. We record this in the formal written method in the ones place, but we also notice that we have 1 remaining, and we record that by writing OR1. 58 divided by 3 is equal to 19 with 1 as a remainder. I've only one more thing to do before I finish recording today's tutorial. I need to examine Greg's puzzle. We can see from the picture there are 4 running lanes. Remember RICE: read, illustrate, calculate and explain. While using the question and the illustration, I can work out that I actually need to divide 56 by 4. 56 divided by 4 leaves a quotient of 14. I can explain my answer by saying that there are 14 beanbags in each lane. Greg asked us the second question. He asked us how far the furthest beanbag was away from the start line. The first beanbag is 10 metres away from the start line. It wouldn't make sense to have the first beanbag on the start line. We've got to always use the context and think about the question in the real world. The beanbags are 10 metres apart. Let's illustrate that. We know that there are 14 beanbags in each lane. We worked that out already. There is 1 beanbag every 10 metres, so 14 multiplied by 10 is 140. The furthest beanbag is 140 metres away from the start line. Now that you've practiced dividing a 2-digit number by a 1-digit number with me, you are more than ready to complete your independent task. So as normal, good luck.